Hey guys, Travis Gillespie, and in the last video, we went over identifying arithmetic sequences. This time, we are going to move forward from here and actually um, find something called the nth term of an arithmetic sequence. So I'm just going to border that guy up, and let's just get out of the screen, by the way. So here we go. I'll scroll back over and then down some. Cool. So here's my problem. Or actually, suppose that you want to find a term that's way out in the arithmetic sequence. And let's say it is actually the 21st term. And my sequence here is 7, 5, 3, and 1. And well, the first thing I've got to do is find a pattern, see if there is a common difference. Well, 5 minus 7 is -2, and 3 minus 5 is -2, and 1 minus 3 is also -2. So let me just do one last thing here, because this 3 dots is saying, hey, yeah, you know what? These are, these numbers are still moving on. So now I'm going to go back and, well, one way I could actually find this 21st term here is to say, well, let's count out the next value. Let's just subtract 2, and I could keep subtracting 2 21 times, or actually 20 times, because I already have my first value. And it may take a while. There is actually another way of doing it that's faster. There's actually a formula and a way of systematically finding this 21st term. And here's the formula. A sub n, that equals a sub 1 plus n minus 1 times d. And I'll talk about what all these terms mean in a second, but this is the actual formula to finding not only the 21st term, but any term in an arithmetic sequence. Well, it looks a little bit scary at first, I know, but once you get it down, it will come faster and be easier. So this is how you're going to write this function, where the domain is the set of natural numbers. Remember that arithmetic sequence. So the first thing we're going to do is write the very first term as a1. So a1 is the very first term in the domain. Well, that first term is 7. In this case, a1 is 7. Cool. So a1 actually corresponds to the first value, then a2 would correspond to the second value or the next value after a1, and so forth. a3, the third value, all the way down to, well, a21, the 21st value. So another way of thinking about this is, well, um, a21 represents y when x represents 21. So a21 is equal to y when x equals 21. Cool. Cool. And then also a actual generic term would be a sub n, where n, this could represent or mean the nth value, where n could be anything, the nth value where n is anything. That's why we have a sub n as the left part of the equation here, because you can plug any value into a sub n. You could call it a1 or a sub 1, a sub 3, a sub 21. Cool. So let's move on and actually calculate what the 21st term would be. And what I'm going to do here is say, all right, this is how I would write this equation. So I'd write a, then sub 21, and well, a sub 1 is actually going to be